Hello to my wonderful little 7th graders. I hope that you enjoyed your first video. I hope that you thought opposites were pretty easy to understand. The number system is a big deal in building your foundation for algebra. So it's important as we get ready to start learning about equations this year and especially next year that you really understand the number system. So that is part of what we started doing, and we are going to continue that today as we talk about topic 1, section 2. So if you could please head up your paper. Remember that you do have to submit a picture of your notes in Canvas in order to receive credit. Please do not submit them through Facebook. That is not a way that we will be grading things this year. It makes things very, very confusing. So please make sure that you have good handwriting and you get the complete examples, because that will not only help you a little bit later on as you practice, but when you write things down, you're more likely to remember. So please make sure that you are taking good notes and then you submit those for your credit. I don't know about you all, but I just need a little bit of humor in my life. I feel like sometimes laughter is really a good way to just put into perspective that we're still very, very blessed and lucky, and you can cry about it, but it's better to just laugh. This is not my bulletin board, but I really like it. It says treat your mask like your underwear. Do not share it. Change it daily. Make sure it's clean. Do not borrow or lend it, and make sure it fits snug but not too tight. I know none of us have ever had to wear a mask before, and I'm much older than you, and I haven't in my life experienced a time when I needed to wear a mask in public. But I hope that you are making the best of it, just like we are making the best of virtual learning. Everything happening right now is not ideal, but it's not the worst thing that could happen to us. So treat your mask like your underwear, and let's make the best out of this situation while it lasts. Here is our lesson overview, or our learning target for today. Students will be able to, or I can, identify rational numbers. Now that's super easy to do, and it makes you sound super smart. It's probably not something you've heard of before, but it's very, very easy. And I hope that when we finish, you'll tell your parents or grandparents that you can talk about rational numbers. And I bet they'll be like, wow, rational numbers, what's that? Students will also be able to convert rational numbers expressed as fractions to terminating or repeating decimals. So there's a couple things in today's lesson, a lot of vocabulary, but just really like one skill that you've done before. The essential understanding says rational numbers expressed as fractions, which you've used before, can be written as decimals by dividing the numerator by the denominator. Wow, that sounds really fancy. So we are going to learn to convert and identify rational numbers. Our standard is on the right side, 7.ns.a.2d if you follow along with those or if your parents are interested. So we are still working in the 7 for 7th grade and in the NS for number system. All right, if you could, please write my question down. This is going to be the very first thing that goes on your notes. This is kind of like our big question of the day. How are rational numbers written as decimals? So please write my question on your notes. If you don't care, go ahead and underline rational numbers and decimals, because those are our bold words. Let's talk about what a rational number is. Numbers have classifications. They probably haven't before. But this year, as a big 7th grader, numbers have classifications. So let's talk about our umbrella of numbers. And do not make fun of my drawing. I am not an art teacher. I am a math teacher. So under our question, how are rational numbers written as decimals, let's draw us an umbrella. Okay, so I have this umbrella. It's very, very pretty umbrella. On my umbrella, I'm going to write real numbers. Well, what do umbrellas do? Why am I writing this? Umbrellas cover things. They take care of things. Real numbers cover every number on the planet, whether it's a whole number, a fraction, a decimal, whether it is an imaginary number, which you won't learn about till high school, but it's very, very cool. So real numbers are everything. Every single number ever. Like if I said footwear. Well, gosh, y'all, footwear could be a lot of stuff. It could be your flip-flops. It could be your boots. It could be even under boots, like you have cowboy boots, you have muck boots, you have dress boots for ladies. As far as footwear, you could have tennis shoes, you could have basketball shoes, you could have high heels. So real numbers is like every number. We are not breaking them down into any classification. We do have two big classifications under real numbers, though. We have rational numbers. And I'm going to abbreviate numbers just because I'm kind of out of room. And we have irrational numbers. So everything is a real number. Every number. Every fraction. Every decimal. However, I also can further break that down into rational numbers and irrational numbers. So I have two classifications. That's kind of like gym shoes and dress shoes. Just different classifications. And Jordan really likes shoes. It's really easy for me to relate things to shoes, I guess, because he's always been super obsessed with them. Jordan is my son, if you weren't sure. Rational numbers are the majority. So under rational numbers, we have three big classifications for 7th grade. Next year we'll add to that. The umbrella gets bigger. But this year there are three classifications, and this is just vocabulary. I feel like people who are not confident in math kind of like vocabulary because there's no application to it. I can memorize the vocabulary. The first of the three is integers, which we talked about yesterday. Integers are whole numbers. Ooh, that is a very ugly W. Positive and negative whole numbers. Today, we are going to add to that repeating decimals and terminating decimals. Now, you've probably never heard either of those classifications before, and that is okay. Now, I told you rational is going to be the majority, and it is. So under irrational numbers, which is very sad and lonely at this time, we have decimals that do not terminate or repeat. Because if it terminates or repeats, it's rational. I know that's probably a little loud when I write. That is my Amazon version of an Apple Pen. It was much cheaper, so we're kind of just going to have to listen to that little noise as it writes. But if you were wondering what that is, that's it. Okay, so real numbers is everything we're talking about so far. Rational numbers includes integers, which are whole numbers, repeating decimals, and terminating decimals, which we're going to talk about in just a second, and irrational numbers, which are decimals that do not terminate or repeat, because those fall under rational. If you need a minute to get all my umbrella information copied down, just pause the video. Now that we know that repeating decimals and terminating decimals are rational numbers, let's talk about what they are. If you want to wait and take your notes after I speak, I think that would be better. So if you would just give me your attention, and then you can pause when I finish and copy this down. So repeating decimals do just what they say. They repeat. Sometimes it's the same digit. Maybe it's only one digit. But sometimes it could be a group of digits. So what that might look like could be 2.72222. Now you've probably never saw these little dots before. Maybe you have, I don't know. Those little dots mean that this number continues, that it is not finished. This is not exactly the best way to write this. If we were going to write this number, instead of having those 4 2's with these dots, we would simply say that this is 2.72, and above the 2, we would put that line. That line lets other people know that that 2 is going to repeat, just as far as we could ever write it. To infinity, that 2 would be there. They don't have to have a whole number. This one had a whole number of 2. It could also start with that leading 0. 163, 163, 163, ... So again, we have the ... dots that let us know, usually, not always, but usually they'll have the dots, that this goes on and on and on. So I'm also going to rewrite this using the line. Now if I pick out the group of digits that repeats, it's these 3. I always want to use the first set of digits that repeats. This is correct. If I were to write it like this, this decimal is incorrect. This is incorrect because of that 1 at the beginning. That 1 is part of my sequence. So I should not have that extra digit there if it's part of the sequence. Now I did have an extra digit here with the 7, but that was not part of my repeating sequence. So there is a difference. The 1 was part of the repeating sequence. The 7 was not. So that's a difference in where that line goes. Terminating decimals, they stop. They end. I don't know if any of you have watched the Terminator movie. They're very, very old, but my husband really likes them. The Terminator, like, he killed people. He did protect a lady, I think, but then there were people trying to kill them. So when you think of terminating, that is kind of like the Terminator. That is ending things. They also have no remainder. They are going to be whole things. Maybe they're positive, 6.91. Maybe they're negative, negative 2.3. Maybe they start with a leading 0, 0.412. So they can have a different number of digits. This first example has 2 decimals. This second one has 1 decimal, and the third one has 3 decimals. So they can have a different number of decimals, but they stop, they end, they're finished. That is a terminating decimal. So if you don't care, please pause the video and get caught up. Okay, finally, let's practice really quickly. I would like you to pause the video. There are 4 practice problems here. I would like you to label these as rational or irrational. When you've done that, you can play the video to check your answers. Please write down the example and how you classify it. Okay, I hope you went ahead and you classified each of these as rational or irrational. Let's look at the first one, 0.474645. Now these dots, we know that these dots mean that this number continues. That is not all of the number. That doesn't necessarily mean it's repeating though. Let's look at the decimals. 47, 46, and then 45. So because of this digit, the 6, the 4, and the 5, this is going to be irrational. If those numbers were the same, then it would have been rational. The 4 is good, but this digit, the 7, the 6, and the 5, that digit is wrong. Example 2 is negative 2.7. You would classify this as terminating, meaning that it is rational. And that's because